Okay, now that we've got our engineering environments window open right there, just a few things to be aware of on the Generals tab is basically your introduction of your job. Now, what the job name, job number, address, detailer, and company would be relating to is basically the information that gets printed on your report when you generate these for your customer or the guys on site or the engineer. So these details will be included within those reports as mentioned. Getting to the code selection tab right there within your engineering environment, we have the ability to select the country code of which we need to use for engineering. Now, do take in mind, currently we only have the Australian and New Zealand code available for our panel engineering, but with our truss engineering, we have the ability to engineer top hat trusses with any of our country codes right there, being New Zealand, Australia, European code, US, and South Africa. After selecting your country code, for my case, I will be sticking to the Australian code. Selecting the wind code, you have the ability to select a previous version if that would be required, but currently we have included the new and updated wind code for the Australian design codes. In the Select Engineering Module tab right there, we have the ability to select our modern Scottsdale Engineering package or the previously used Legacy mode. Now, the Legacy mode can still be used for the older projects if you need to re-engineer any of your existing projects, or if you are starting with a new project currently still requiring your engineering, I would highly suggest using the modern Scottsdale Engineering module. As soon as you click on the help button right there, you'll see a small description of what the modern versus the legacy engineering entails. Now we go to the next tab in building dimensions. In your buildings dimensions tab, we have the ability to go insert some of our data for this current project that we are dealing with. Now currently we have our building width, meaning a 6 meter from that section there. We can also click on the help button to give us a little bit of a guide. So you see the width is the shorter end of the two dimensions and the length being the longer one. Now, as you can see there, it is taking into consideration the entire dimension of this building and not just a single spanning point. So for my current situation, I have a 6 by 12 meter building. The average roof height, if we go click on that help button right there, is going to give you a very nice indication of what you are currently dealing with. Currently, my dimension for my walls itself is about 2.7 meters, and everything there on top of would be indicating the pitch of my roof, and a measurement from the starting point of my pitch to the apex of my roof would basically take the center of that point into consideration as an addition to my wall height itself. So in this case, we'll say my wall height is 2.7 meters, and we'll add on top of that just a couple of 100 millimeters to consider the average roof height being measured from the center of the roof to the ground floor level. My current pitch of my roof is set to be 20 degrees. Now there is a difference between the minimum and the maximum. Now taking as an example a project where you have two different pitches on the roof, for example a carport or an extending veranda of some sort outside of your property or even inside the property, and you're using two different pitches, this is where you will be indicating the minimum roof pitch and the maximum. So for example, you have 3 or 4 different pitches. You'll start with the minimum being whatever it would indicate for that project, and you would place the maximum right there. In my case, I only have one pitch to deal with, as you can see right there. The shape of the roof, in my case, is a gable roof. Now, for example, if this project only had hip points, then and only then you would consider the hip option. If you have all hips but only one gable, you will still be using the gable option. The reason for that is on a gable side of your roof, you have a lot more wind uplift that it would be calculating on the structure, and a hip is calculated with a lot less uplift. As soon as we're done on the building dimensions, we're going to the building information tab. Within the Building Information tab of your engineering environments, we are going to have a look at the information provided for this exact project. In the first one, we have a look at the building use, as we need to state what the building would be used for. In the first case, we've got residential domestic, classrooms, garages, general industrial, offices, no storage, public assembly areas, shops and similar commercial, storage, and uninhabited farm buildings. In my case, I will still just be sticking with a residential domestic. It is quite easy to differentiate between these projects, as it would be indicated on the architectural documents. Next up, we will need to indicate the number of stories provided on your project. In my case, I only have a single story that I'm currently wanting to engineer. Next, building enclosure. It is going to ask in this tab, is the building enclosed, partially enclosed, or completely open? We do have a very nice help text box to click right there, which will open up this window explaining what it would look like if a building is enclosed, partially enclosed, and completely open. Now, going from enclosed to completely open, I would say that having something like a carport that's sitting on posts would be considered as a completely open structure. So in my situation, I currently have an enclosed building. The site altitude that would be measured is a distance from sea level to the elevation level of the current site address. Next, we go to the Importance Level tab right there. In the drop-down menu for the Australian Engineering Code, we have 1, 2, 3, and 4. We can also click on the Help button right there to give you more clear indication of what this means. For Importance Level 1, it would be indicative of farm buildings and farm sheds, isolated minor storage facilities, and minor temporary facilities. For Importance Level 2, we've got low-rise residential construction, buildings, and facilities below the limit set for Importance Level 3. So as you can see, it is basically an indication of the risk of human life lost. So the higher the importance level, the more risk. So the higher the importance level, the higher the risk of more lives lost if a structure failure should occur. Next, we'll go to the gravity loads for the roof. Make sure that the Allow for Roof is checked on. If you are quite familiar with how the load cases work and how to divide between dead and live loads for the roof on top and your ceiling structure itself, this would be fairly simple to indicate those loads in the right order. But for those who don't know, the dead load itself is basically the self-weight and the materials added onto the roof. Should it be panelized system with your isolation included or purlins in that case, and then your roof covering, then obviously you need to calculate and convert into a kilopascal weight right there. Now, taking into consideration just a normal simple roof structure like having your trusses in there, or in the case of a roof panel with just some purlins, and you would indicate what type of roof covering would be, like roof sheeting like IBR or corrugated sheet metal, or you go to the roof tiling or concrete tile option, that would obviously indicate a larger weight added onto the structure. So for this case, I'm just going to use a simple weight of sheet metal roofing on top of purlins, on top of my panelized system right there. Generally, you go to about 0.2, 0.3, which would actually indicate about a 30 kilogram weight. The next one is a live load. Now in this case, live load is indicative of the serviceability and especially movement on top of the roof. Now when you start construction, obviously you will have some people walking on the roof that would actually be required to build the roof and also attach the fixings and the covering on top of those elements as well. Now before inserting any of the loads, please make sure to consult with your engineer what load allocations you will need to use for the structure that you are going to build. Adding a point load factor on top of your roof is actually an indicative point of saying that I am going to add that load onto that point at a random time. So it's going to take a 1.1 kilonewton load and add it on the entire structure at any point and say that it should carry this load when added for a temporary time. You can apply a redistribution factor, which would basically say that I'm distributing this load between its neighboring elements. Say, for example, you have one truss in the center and two trusses right next to those points. You can have those indicating a distribution point, saying that the center truss will actually be carrying a 50% of the load and the two side ones would be carrying 25 and 25. I tend to be a little bit more on the conservative side, and I would say that in my case, I would say 0.75 is a 75% of the full load, where the full load would be indicated as 1, and 0.5 would be indicative of 50%. Now we get to the ceiling underneath the roof structure itself. Within the text box of our dead load for the ceiling itself, we can include a ceiling batten as the self-weight, the ceiling panel itself, and also your insulation or whatever type of ceiling board that you would be using. Again, this load will be indicated to you by your engineer. In my case, generally would be a 0.2 placed right there. Next, we have the live load indication right there. Now, in most cases, you will not be considering a live load as there would not be any indicative load placed right there. If you go to factors like adding ceiling fans or any additional elements right there, we do have a separate position where you can allocate those loads on separate structures that you would be able to manually control when in the design phase. For the point load on the ceiling itself, the same applies as we have done for the top. Should you require a point load for the ceiling, you can also have the ability to apply a redistribution factor. Now, please make sure to consult an engineer before applying these point loads, as they would give you a better indication of what load to use. As soon as we go to the gravity loads for the floor, we're going to select the checkbox there to turn that on. If you have a double-story building and you're going to be using floor trusses for that project, this is what you'll be using to allocate those loads for those trusses. Now, within the floor loads that will apply, if you have a look there, this is the dead load and self-weight that you'll be applying in that first text box right there. Now, depending on what finishing and what type of materials you'll be using, that is the weight that you'll be applying within that text box right there for this project. Now, depending on what material and what finishing you're going to be using for this structure, that is what's going to be applying the weight as a kilopascal load into that dead load text box right there. The next one is our live load for the floor. Again, whatever would be required for whatever region or country you'll be applying these loads for, please make sure that your engineer has advised what the loads should be for this project. Now, going forward, we've also got the point loads that would be applied right there. The same applies as the gravity loads for the roof with the redistribution factor as well. You can turn that on and apply a redistribution factor in that text box right there should you need to. And then we also have a live load for the balcony and also a point load. We will be explaining this more in detail as soon as we go to the floor truss engineering. The same applies for the ceiling under the floor. Should you need to apply the weight depending on what material you're using, that is where you'll be inserting the dead load for that. Next is the live load. Should you have any loads applicable for it, you'll be applying it right there. And next we've got a point load. So please make sure to consult your engineer about the loads applied for the region that your project is in. Next, we'll have a look at the wind code. First off, we need to make sure that we have the wind application activated. The first option we have is calculate the design wind speed. Now, selecting that box there, we have all the additional information that we need to insert, which will automatically give us an output for the wind speeds. Now, going into the wind region, we can select one of these regions. And if we go to the map area right there, it is going to give us an indication of the locations that these regions represent. Okay, so let's say we're going to go for the B1 region right there. We'll go to that drop-down menu and we'll select the B1. Terrain category, if we click Help, this window that has appeared is a direct copy from the Australian code. As it states, terrain over which the approach wind flows towards a structure shall be assessed on the basis of the following category descriptions. Now, as a short description, what this document describes is what type of effect this structure that is going to be engineered has on the environment should there be a structural failure. Now, if you have a look at all these descriptions, for terrain category 1, very exposed open terrain with very few or no obstructions and all water surfaces. Example, flat, treeless, poorly grassed plains, open ocean, rivers, canals, bays, and lakes. If we jump to terrain category 2, open terrain including grassland with well scattered obstructions, having heights generally from 1.5 meters to 5 meters with no more than 2 obstructions per hectare. Example, farmland and cleared subdivisions with isolated trees and uncut grass. And then we jump to the next terrain category, 2.5, terrain with some trees or isolated obstructions, terrain in developing outer urban areas with scattered houses, or larger acreage developments and more with more than 2 and less than 10 buildings per hectare. Most commonly used would be the terrain category 2.5. So as it states at the bottom of this document, selection of the terrain category shall be made with due regard to the permanence of the obstructions that constitute the surface roughness. So yeah, please make sure to select your categories accordingly to your project. So normally this is going to be around 2 to 2.5, depending on the terrain that you're going to be building. In the next drop-down menu, we've got the shielding menu. Would it be full, partial, or none? We have a nice help button to guide us through this. As you can see, having full shielding built behind any and all obstructions, partial in between obstructions, and no shielding, having no obstruction for the wind. So as you'll see there, full shielding shall apply where at least 2 rows of houses or similar sized permanent obstructions surround the house being considered. And as it goes on, it gets less and less shielding. Normal cases, you'll probably have partial to full, depending on where you're building. Next, going to the drop down for the topography. If the terrain is not steeper than 1 to 20, that's fine. Going to a hill steeper than 1 to 20, it's going to give you this window where you'll have to insert all of this data that you will receive from your local engineer. And again, if you go to an escarpment, same thing applies. Okay, but for this example, we'll stay on the terrain not steeper than 1 to 20. Should you need to apply snow to the project, you can go select on that category right there. In the snow applications menu, you can calculate the snow load by the region. You can enter the ground snow load, which will also calculate a service design snow load and the ultimate design snow load. And you can also enter the design snow load manually. Should you have this data already given to you by your engineer, you can easily go and insert this by going to the drop-down menu and selecting the region from the map. If you have a look there, this is the Australian map. And just by doing a little bit of research, you can easily see the amount of snow that will be applied within these regions. You can see also with the data given there, alpine and subalpine, New South Wales, Victoria, Tasmania, and should be applied accordingly. If we go to enter the ground snow load, we can still select what region we'll be applying this in, and we insert the ground snow load. For example's sake, should this be 0.5 kPa, and remember this is for the ground snow load. As it states, it is going to automatically calculate the service design snow load and then also the ultimate design snow load. But for this example, we're going to make sure that we have none selected And we're going to click on Generate Report and close. After generating the report, this PDF document will appear stating all the data that you have inserted, stating all the load cases that will be applied from the gravity loads for the roof and ceiling and the floor as soon as we get to that point, the wind calculations, and also giving you a load summary in the bottom section there.